Jim collects books. He will write a program to store data about his books. The program design has a record data type structure with five fields for each book. So this is going to be a record data type. Even though it's a record data type in pseudocode, it's going to be an object in Python. And it's going to have one record. One object is going to have title, author, reference number, fiction, last read as fields. And they're going to have their values. They are ready to store their values and they have a particular data type to store. Write a pseudocode to design an abstract data type with an identifier book. Okay, so it goes like this. We want just the pseudocode. And if it is a abstract data type with identifier book, so it's going to be a record type. So we start like this. Type book. Type book. And then you should have the attributes between type book and end type. End type. Okay, then you have to declare the variables. What are the variables or what are the field names? Title, declare. Use the same name that they have given, right? Title, and it is of data type string. And then declare author of string. Declare reference number, ref num, as reference number. You can see that it says 4-digit reference number. 4-digit reference code. So it should be number, right? It should be integer. Fiction of data type string, it's true or false. So it's going to be Boolean. And then declare last read, that is a date. Last read, and it's going to be date. Okay, that's how you declare the record data type in pseudocode. To make it more neater, we'll keep cap spaces like this. Okay. The records are to be stored in a random access file. Okay. So what we are going to do is when you're implementing this will be implemented as an object. I mean, first as a class, and from the class you can create the objects, and these objects are going to be stored as a random access file. In other words, it's going to be stored as a binary file. A function hash takes a single parameter, the reference number, which is here. Right, it's going to take the reference number and calculate a hash value. Now, the purpose of this hash value is to find the memory address to store the record. So it's always better to use a data item from the record itself to calculate the hash value. And then the hash value will be used to find a location in the memory to store this object. When you are searching, since it's a random access, right? Random access means you can access the file directly without going through each and every record in a serial access. So since it's a random access, again, you can take the reference number and calculate the hash value and easily find where it was stored. So that's the reason why we take an existing data item from the record itself. So hash function can be different program to program. So here they have given a hash function, which is taking the reference number, calculating the modulus divided by 2000. You take the reference number, divide by 2000, find the modulus. Modulus is the remainder. And for that remainder, you add 1. So that's going to be the hash value. Okay, so when you are storing the record or the instance, you will use the hash value like this. When you are looking for the stored object, we'll be calculating the hash value just like this. Same function. Understand? Hari, Sanjana, did you understand the purpose of the hash?
Yes, sir.
Yeah, it is used to find the location in the memory. And we calculate the hash. It's better to calculate the hash with the existing data in that object, so that later on when we are looking for the object, we can use the same method. That's what we are going to do here. Write the hash function, program code. Okay, so it's a function, and you know it should be start with def, right? So let's start coding it. And when you're using binary files, you need to import a library which is called pickle. If you can't remember the binary file processing, go through that video I have uploaded about binary file. Let me show it to you. Let me send the link. And there I have clearly explained how binary files are implemented and the program as well. And it's very important that you run that program, right? Code that. You watch the video, pause the video, and run that code and see how it works. Binary file handling, this one. Uh-oh. This one. This time they might ask binary files, so it's better you pause the video and run this, code this, and test. Let me check. Binary file example. Right. Okay. So let's code this. Right. So when you're handling binary files, you need to import this library called pickle, right? So import pickle. Right. So they want us to write the function for hash. Right. So it's going to be like this. Def. I'm going to call this hash brackets. And it's going to take one parameter, right? It's going to calculate the hash using the reference number. So with the reference number only, it's going to calculate the hash value. So reference number should come into this as an argument, right? As a parameter. The argument should come to the parameter. So here I'm going to use ref number as a parameter. Okay, now the calculation. How do you calculate? I'm going to call this hash value val equals, you can even call address because it's related to the memory address. Hash value. How do you do it? We need to take the modulus of reference number divided by 2000, right? So ref number mod, that is percentage 2000. And for that, you need to add 1. Understand? Okay. Sanjana, Hari, are you there?
Yes, sir.
Okay. And then this is a function and it should return the hash value. So return hash val. Okay, let's just see how this is calculated. They have given some example data of the reference number. For example, 4563. So 4563 mod 2000, you're going to get 563. And for that, if you add 1, it's going to be 564. That's fine. Let's take another example. They have given 7865. 7865 mod 2000. 1865 and add 1866. Okay, let's take another value 6754 mod 2000. Okay, fine. That's perfectly okay. Right, so the hash function is done. That's this one. This one. Huh? We shall add 3 book records to the file mybooks.dat. Right now, these binary files, they have an extension. Usually they have extension of dat files. Right, it can be any other format. You can give any other format. You can think of any format and put it after dot, except txt, because these are not txt files. What's the difference between text files and binary files? In text files, we store normal text, normal ASCII characters. In binary files, it stores a computer readable format. A computer readable format, not human readable format. Right, which is actually binary, but it uses a coding system to represent that on the notepad when you open it. But it's actually a set of binary values stored. The actual binary representation of the values. Whereas in text file, it's a human readable format that we store. So when you open the text format, we are able to read it. But when you open the dat file or the binary file, you won't be able to read it because the binary values are represented as weird, codes. So all you see is codes which do not make sense. We shall add 3 book records to the file mybooks.dat. First watch, okay? I'll give you a chance. Add the code for the test data for 3 books. Title and reference number only, which is originally stored in an array list. So these values are going to be stored, title and reference number are going to be stored in 2 arrays, 2 1D arrays. Right, add the code for the test data. Right, these are the test data which are going to be used in creating objects. So let's get the test data added to this. Titles, first array. Right, have they given it? Yeah, title list. So you have to use the same name. Right, so they have given a title list. You can see the first one, they have left it because it's the 0th place. So they're going to start with the first index. Now you also can start typing. Right, these are the two arrays for test data, right? These two. And you can see the first index is left out. That is because both these first indexes are actually 0th index. Right, so the program is going to use 1, starting with 1. So that's why they have started with the first index. Right, so can you do up to this point? Import pickle, create the hash function, and then create the 2D arrays. I mean, two 1D arrays. Hurry up. Let's move to the next one, right? Write program code to write the data for the 3 books from the array list to the file. So in the array, you can see there are 3 records: first record, second record, third record. And for all these three records, I mean, 3 fields, 3 objects, we need to create uh, a method to store it. So that's what we are going to do now. Write a program code from the user for a book reference. Output the disk address where the book was stored and the title and the reference number of the book. Now, disk address is the hash. Right, so let's see how we're going to do this. We're going to have a procedure or a function. def write to file. No parameters needed. Ten marks. From the user for a reference number. Why do you have to give? Why do you have to collect it from the user when it is there in the array? No? Okay. Anyway, write to file, and then first we need to open the binary file, just like a text file is open. So it goes like this. We need to have a variable first, like this, equals open, just like the text files, right? And then inside you need to have a binary file. So let's have something like books dot dat. All right, so this is the file where we are going to write these records to, objects to, and after that we need to give the right to open this. So we are going to open it for writing data. So we have to open it with a tag call or a parameter called WB. WB stands for write binary. Write binary. Okay, then what should you do? What should you do? What should we write to the file? Title and the reference number. And the title and the reference number. No, this is the other one, no? This is opening, this is searching, right? So we have to write. This is the writing part. Okay, so the binary file is open. Now we are going to do it for 4 records. 1, 2, 3. Sorry. Yeah, we are going to do it for 3 records. So we need the for loop here. For index in range 1 to 4. Why 1 to 4? Because then it goes from 1 to 3. 1, 2, 3. 3 rows. Because we are going to store details of 4 books. Sorry, 3 books. Okay. Right. So the next is to call the hash function by passing the reference number. Where is the reference number coming? It's coming from this array. So the question is a bit wrong there because it says, no, it's fine. It's fine. It's correct. The question, the next question only asks for the reference number. That's when you're searching. This is writing. So when you're writing, you have to take the reference number from this. Okay, so for index in range 1 to 4, we are going to call the hash function, hash, and we need to pass the reference number. So the reference number should come from this particular array. So how do you access the array? Array name, watch first, and then square brackets. Inside the square brackets, what are we going to have? Can you tell me? What are we going to have inside the square brackets?
Index.
Index, good. Index. So index is going to start with 1, which means reference number list index means it's going to read this one, 4563. Okay. Since these are numbers, reference number was number, right? Yeah, integer. We'll have to convert this into integers, no? Otherwise, how is it going to calculate this? Let's see, yeah. Right, so this is going to be called, and the hash function is going to return the hash value, right? And that should be stored. So I'm going to call this address. The memory address, but it's going to return the hash value, which is going to be used as an address. Okay, so the next thing is to write. We need to write this as a record. What are we going to write? We're going to write the title and the reference number, right? Or is it only the title? Right, we're going to write the data for the 3 books from the array list file. Just says data. Okay, right, now the address is calculated, right? This address is the memory address. Okay, so when you in binary files, when you calculate using the hash function, when you calculate an address or location to the memory, you need to use a particular function called seek and put this address there. Why do you do that? Seek will look for that address, and then only we can write. So it's seeking is like moving the, whatever the pointer you use on the storage to the correct location. So this is how we write that. We are going to store in this file, So this file has a certain memory area allocated, and that memory area is written into this variable called book file, because initially we have opened the whole memory in this file, and that is written to this variable. So when you are looking for the exact location to store this, you need the name of the variable where you open the file. So that is book file. And then we have to use a function called seek. Right. Inside seek, you need to pass this address. You calculated an address, a random address. Now for the seek function, you have to pass it. Why? Because then only the pointer will search for the location and point to it. So book file, which is the memory, after reading the whole file, seek, find it. What are you going to find? You're going to find this address. the value in this address. Okay, and you can see that the address was calculated using the hash function. Right, now we locate the address. So the next thing is to write the data. Okay, write the data into it. Understand? We are going to write two values. What are the two values? We are going to write, now they say data. So we'll take the title and the reference both. Okay. So this is how we write pickle dot write. Sorry, not write. Dot write was used in text files. Pickle dot dump. Right. And then first we'll dump. Dump is for writing actually. First we'll dump reference number list and index, which is going to be this number first. And after this, with a comma, you need to give the name of the file that you open. I mean, the variable or the file handle that you use for this, which is book file. Put it there. Okay, so this will write the reference number into the file, binary file. Understand?
Yes.
Okay, so not only that, we need to write the reference number also into the same. So I'm going to use the same line. Pickle.dump. This time it's going to be reference. Yeah, actually the first one should be title. This one, titles. First we write the titles like that. And the second one is reference number list and index. And we are writing it to the book file. That's how it should be written. Pickle.dump. What you are dumping and comma to what you are dumping. Okay, so after that, so why are we running this 4 times? Because we are doing it for 4 objects. Right, after creating this, we'll put a message, print new record written. New record is written. That is the first title and the reference number. Then this one and the reference number, and then this one and the reference number. Then that's where you stop. Okay, so the next thing is in the main program, we'll print file with pre-record. search book. Again, the file has to be open. So book file, binary file is open. All right, this time it's not open for writing, it's open for reading. So it has to be RB, read binary. Then we had to ask the user to enter the reference number because he's going to search the reference number, right? So this ref number equals int input enter reference number. Right. Yeah, the user will enter the reference number. Okay, it is the same reference number that we used to store the file. Now we need to calculate the hash again. Why? Because hash is the place where it is stored. So how do you do that? It's the same method. We call the hash function by passing the reference number. Right, so we had to pass the reference number this time, which is this one. Remember, these reference numbers should be numbers, okay? Not text, not string. So reference number was input by the user and it is passed into the hash function to calculate the address. Okay, now if you have the address, what you have to do? You have to seek. So use the same seek function to seek the location. Understand?
Yes.
Okay, now the pointer goes to where it was stored. Okay, and there we have written two values. First, the title. And then we have written the reference number. Okay, so we have to read these two, right? For reading, we use something called load. So first of all, let's have two variables. This title equals pickle dot load. So for writing, we use dump. For reading, we use load. Pickle dot load. And then you have to pass the file handle, which is book file. And then this ref num equals pickle dot load book file. Okay, so we read the two data items. Okay, next is to output. Let's output print. Let's output the disk address. Disk address is okay. That is this address, this one. Let's output the address and see how it looks like. Then let's add these two values, title and the reference. Print book reference number is this ref number. Let's output the title. Print book title is this title. Okay. Once you finish that, you have to. Oh, I have forgotten diff. Don't forget diff there because it's a subprogram. Okay. Once you have finished this, you have to close the file. As the how do you close? You have to use the file handle, which is book file dot close, just like the text files. Okay, now I'm going to bring this write to file. No, that's fine. Let's have it there. Okay, let's call this subprogram by its name, search book. Okay, let's see whether it works, right? Record written, record written, record written. File with 3 records now created. Enter reference number. So I'm going to use the same reference number, one of the same reference numbers. Let's see, 4563. 4563. Okay, disk address. Reference number is 4563 and the book title is Jazz. There you go. Correct, right? Understand?
Yes, sir.
Okay, let's try another number. This time, let's see, 6754. 6754. Okay, there you go. See the disk address 755. Using the hash function, it calculates the hash value, which is the address 755, and 6754 is under the light. Correct. Okay, let's try the last one, which is 7865. There you go. Understood?
Yes.
Now, if you go and open the file, okay, now this file is recorded, created exactly where you have uh, stored your Python file. There you go, books.dat. Now, if you open this file in Notepad, you will see it doesn't make sense. Right? Some of the values are there, but the rest doesn't make sense. That's how a binary file will look like. It is not completely readable for humans. Okay, can you finish it and run and test? Now, Sanjana, remember now here we didn't really write it as an object. Okay, it is not now even though they ask you to create a type record for this one, it is not an object that we wrote to the binary file. It was just two pieces of data items that we wrote. So the other method is to use double OP and write these two data items as an object into the binary file. Okay, so that's what I'm going to show you in the next class. We'll implement the same thing using an object. But here what we did was we just took individual values, pair of values, and then brought to the binary file. Okay. Right. Nice. What happened to Hari? Was he there in the second session?
Not sure, sir.
I actually fell asleep to see that you were there and that fellow was not there. Okay, so I hope you understood. So practice this. This can be a possible question. I mean, binary files. So just a recap of what we did.
So for the search book, we should write read binary, right?
Exactly. It should be read binary, just like in text file handling, we used R for reading,
Okay.
we use W for writing, and we use A for appending. And here we use WB, RB, and AB for appending. Write binary, read binary, and append binary. So just a quick recap of what we did. We had two arrays. One was holding titles, the other one was holding reference numbers. And we wanted to write these data into a binary file. So what we did was we came up with the hash function first, because hash is used to determine where exactly we are going to store it in the memory. So hash function is simply a calculation based on an existing value of a data item, like the reference number here. And we use this hash value to find the location in the memory to store. And first we had to open the binary file. So if the binary file is not there, it will create the binary file just like the text file. And then we ran a loop for 3 times, because we have 3 records to be written. And then we read the reference number and put it into the hash function to determine the memory location or the address. And then we used the seek function to move the pointer to that particular memory address. And after that, what we did was we dump. So just like writing in text files, writing in binary is called dump. So we dump the 2 data items into that location. And then we close the file. Then we searched. To search also, we used the same reference number, but we have to ask the user to enter the reference number. First, you need to open the file, binary file for reading. So it was RB, read binary. And then the user will enter the reference number. Again, we need to calculate the hash value. So we pass